Hello everyone, welcome to our topic replacement deposits. This is the another process in cavity filling deposits in hydrothermal solutions. This is also a very important process for the formation of process of mineral deposits. In this video, you have to learn about what are replacement deposits and what are the characteristic features of replacement deposits and different types of replacement deposits and their structures and their characteristic features, and also examples of minerals for different replacement deposits. Let us move to the topic. What are replacement deposits? Replacement is one of the important process in the formation of epigenetic mineral deposits. The chief epigenetic mineral deposits are contact metasomatic deposits, supergene mineral deposits, and hydrothermal replacement deposits. The replacement deposits commonly contain ores of iron, lead, zinc, copper, silver, and many non-metallic minerals. The process of replacement may be summarized as follow. Replacement is the chemical process of simultaneous capillary solution and deposition. By this process, new minerals are substituted for earlier minerals and rocks. The replacement occurs through the action of hot vapor or hydrothermal solution due to capillary solution by deposition. It takes place molecule by molecule. Consequently, shape, size, structure, and texture of the rocks faithfully preserved. Almost any rock may be replaced by ore, but the rapidly soluble carbonate rocks are the most susceptible. Certain structural features such as fissures may also localized replacement. Replacement occurs through the action of hot vapors or hydrothermal solutions. The new minerals are carried in solution and the replaced substances are carried away in solution. It is open circuit and not a closed one. The replacement takes molecule by molecule. Thus, closely spaced sheeted fissures and shear zones, because of their large specific surface, give rise to large replacement loads. There are major four types of replacement deposits. The first one is massive type, and second one is replacement load type, and third one is disseminated replacement type. Each one have the separate characteristic features and their structures. In this picture, we have observed the replacement deposits in a ore body along the fissures. The first type of replacement load deposits are massive deposits. What are massive deposits? Massive replacement ore deposits commonly occur in limestones. They are mostly occur in limestones. The ore terminates abruptly against the host rock. The massive deposits are characterized by great variations in size and extremely irregular form. The second type of replacement deposits are replacement load deposits. What are replacement load deposits? The load deposits are formed when the replacement is localized along thin beds or fissures. In this case, the fissures walls are replaced by ore. The load deposits resemble fissure veins in form, however, they are wider than fissure veins and their walls are wavy and irregular. In replacement load deposits, the structure of the deposits are fissure veins and their wavy irregular forms. The last type of replacement load deposits are dissemination replacement deposits. What are dissemination replacement deposits? These are the low grade ore deposits where grains of ore minerals are found scattered throughout the host rock. The size of disseminated ore deposits is generally large. The massive deposits are of irregular form and of varied in size. The replacement may start from a fissure with bold face of massive against the country rock. It may thicken and thin with wavy outline and rapidly irregular in all directions. The host rock is almost completely replaced and the ore shows abrupt ending against the country rock. The ore may retain original texture and structure of the rocks it replaces. In replacement load deposits, the replacement loads may be massive or high grade or flanked by a fringe of disseminated ore. Here, replacement may start from a fissure with bold font or some prominent centers followed by replacement at many small centers like fissure veins. They occur replacing walls of fissures or thin beds. The outlines of the ore body may be wavy, irregular, and gradational with the country rock. In disseminated load deposits, the disseminated deposits represent multiple centers of replacement and consist of altered host rock and disseminated ore grains. For example, porphyry copper deposits. The mineralizing solution spreads in the host rock and give rise to scattered peaks, grains, and small ventlets of ore scattered within the host rock. The boundaries between the ore and the host rock is vague and gradational. This type of deposit being of a low grade and huge requires large scale mining. The texture of replacement ores is dependent upon temperature and pressure of formation and degree of replacement. Coarse texture is characteristic of high temperature and pressure, while fine grain texture is developed at low temperature and pressure. When replacement is complete, hollow crystalline texture is developed. In case of incomplete replacement, the residual host rock forms part of the ore body. Many precious metals, base metals, and rare metals besides ferrous and non-metals deposits are examples of replacement deposits. These are the characteristics feature of replacement deposits. The various criteria for recognition of replacement deposits as follows. The first one is presence of unsupported residuals of host rock. The country rock that escaped replacement remained as isolated body with the ore mass. The residual rock may show bedding or other structural feature with are in conformity with those in the wall rock. The constitutes support evidence of replacement. The another criteria for replacement load deposits are preservation of rock structures. The structure of the replaced body is sometimes faithfully retained in the ore. This constitutes the conclusive evidence of replacement. Such inherited structural elements may be stratification, cross-bedding, cystosity, folding, faults, or joints. Fossils and dolomitization rhombs are also sometimes preserved. Next, another criteria doubly terminated crystals of ore transecting rock grains of the enclosing rock. Such crystals may be microscopic or megascopic in size. Mineral pseudomorph. A mineral after another of different composition is typical of replacement. Example, chalcocite may replace pyrite cubes and forms pseudomorphs. Next one, irregular outlines of the ore. The wavy outlines of the ore with protuberance and embayments into the host rock, and extreme irregularity are indicative of replacement. The another criteria is intersection of diversity oriented host crystals. Small wavy veins of irregular width which transect host rock indicate replacement. The last one is absence of crustification. This is also one of the criteria to recognize replacement deposits. And presence of mineral pseudomorphs, that is false crystal shape, absence of crustification, and these are extremely irregular outline of the ore body. This is the description about replacement load deposits. In this video, you are learned about replacement deposits and how the replacement deposits are formed, different types of replacement deposits and their structures, their formation environment, the common mineral examples of such deposits. Hope you understand the concept. If you have any doubts regarding on this topic, we can discuss in WhatsApp or Google Classroom discussion. Thank you for watching this video.